Hello everyone. In this particular program we are going to work on a binary tree. So the program has been demonstrated using three different files. We have a header file over here. We have defined some custom user defined data type. We have gone for function prototype in the form of declaration, and we have also got some macro functions. So we'll go through each of them, and we also have a file in which we have defined the body of the function which was been written over here. So let's start with the main function. As we can see inside the main, we have given a call to a reference of type binary tree. So what this reference is all about? So for that reason, let's move to the header file. So once we come over here, you can see that we have got a type div. So we are creating a custom data type. So we are creating a data type which would represent the information about my binary tree as a whole. So what a tree would consist of? The tree would consist of a root node, and this root node will be also of a type called tree binary tree node. So that's what we have defined right over here. As we know that every node will have a data member, and we have gone for a void pointer over here so that we can define the data type later on. So it would give us a flexibility that we can assign integer, character, float, or whatever choice we feel like. The node has got a left child, the node has also got the right child. So that's how the node structure is all about. Now, apart from the root node, the tree is also going to hold how many node we have created. That information we can derive from this property called size. We have created one function pointer which would be responsible for clearing all the garbage value. For that reason, we have given a call to a function pointer. And we also have a function, we can come across a function pointer that would tell the comparison between nodes, but this we would be using it later on. At this point of time, in this particular video, I'm going to talk about a simple creation of a binary tree, and it will count the number of nodes the tree is going to have. That's what I'm going to cover in this video. So as we come back to the code, so we have created the reference over here. So once this reference got created, we have created a tree reference inside the memory. Now we have gone for a call to a pointer variable that will refer to the input that the user is going to give. But why it is a pointer? Well, we will come to that point later on. So once the tree has been created, we are giving a call to initialization function, which would be a very good practice, because since the tree is going to consist of so many other properties, so very naturally they may hold some garbage value or some reference that might create some problem at runtime. So for that reason, it's a good practice to clear all those garbage value. So how exactly it is working? So here we are giving a call to a function called b_tree_init. If we come to the header file, you will find that over here we have gone for a function declaration, but the definition is missing. And this particular function is going to take two parameters. The first is the tree itself, and we are passing a pointer to a function. So let's come to the definition part of this function now. So let me click on this. As I do that, it will bring me right into this particular file where we have defined the body of the function. So as I said, that this particular function is going to pass the address of the tree which we have just now created. Along with that, it is going to pass a reference about a function, and this function is the following one, where we are giving a call to the system defined function that is present inside strlib, that is called free, which will release all the memory. So this is the content of this function which we are passing right over here, and that information will get stored within this particular pointer, which will be holding the information of a function. So what we are doing at first is that we already know that inside the tree we have got a property called root. We are assigning a null value to the root, so that the root does not hold any garbage value in the form of an address. Similarly, we have also got a property called size. We are assigning it with a value called 0, so that it does not hold any random number. That's what we have done. And then we are giving a call to the function that the pointer is holding in order to remove all the parameters in the form of left or right child. These parameters, everything will be removed, because we have given a call to the free function. So that means my tree is just created and it doesn't hold any garbage value. So that's the reason why we have given a call to this init function. Great. So now we start working on taking input from the user. At this particular point of time, I've taken a hard code value that is called 10, but later on I will transform this program into user taken input as well. So what we are doing in this particular line, we created a pointer, and we know that when we work on tree, we are basically making use of the heap memory. For that reason, we are given a call to malloc. So malloc will create a dynamic memory block inside the heap memory, and the address of that block will be stored by the pointer that exists inside the stack memory. So the data is a pointer that exists inside the stack memory, which is going to hold the address of a dynamic block that gets created inside the heap memory. Now once that address has been referred, so now we are going to assign the value directly into that heap memory block. So with the help of start data, because data is holding the address of the dynamic block that got created inside the heap, where I'm passing this particular value called 10. That's great, isn't it? So we have created the pointer, we have created the data, we have taken the data from the user, we are assigned that inside the pointer variable. What next? Well, we have to create the actual node, or we have to create the very first node, that is a root node, and that brings us to a call to a function called binary insert underscore left. So we are inserting a new node, right? So if you look at this function parameter, we have got three data over here. What are these three data? The first data is the tree itself, the address of the tree itself. So whoever will receive this address will be of type pointer, because we are passing an address. The second parameter is null. What is the second parameter called? Well, this is the first node, which is basically your root node. So the root node does not have any parent, hence there is no reference of parent over here, so it is null. And the data that we are going to pass is the third parameter. So I want to show you graphically what I have done. So when we execute a line number 19, this is the formation that has been taken place, and now we want to create this entire structure. So we want to assign the 10 as a root, and the root will have a left child and right child, which is basically null. So let's go to this particular function. Again, we move to the header file, and we'll see that here we have gone for the function declaration, but the definition is missing. So that definition I have defined in this particular file. So let me close this function, and let's come back over here. Let me click on this. That brings us to the function called binary tree underscore insert underscore left. So as we are saying that it will have a pointer, because we are passing the address of the tree, and the second parameter is basically the information about the parent, but this is the root, so we don't have any parent as such, but still we have to define the parameter, which is of type node. And the third one is the data which we will be adding inside the tree, and that what you saw right over here. So this is information that we are going to add, isn't it? Okay, so let's see how this thing is going to work. So that brings us to this particular function. Now this is the very first node, isn't it? This is the very root node, so naturally the root node will not have any parent as such. So for that reason, we are going to check whether this node is holding any address or not. And the answer is no, it is not holding any address. So the content of the node is basically null, right? That's what the thing goes. So since we don't have a tree involved over here, so we don't have any tree, and then this part does not work, so we come right over here. So if you remember, the node has got a property called root. The tree has a property called root. So if you remember this, so what we are assigning over here, we are assigning the address of this particular root. That's what we are doing it. And since we are assigning the address of the root, that is the very first node of a tree, so for that reason we have declared a pointer to a pointer, because it is going to pass an address. So the position, which is basically of type tree node, is going to hold the address of the root. Please follow this line. The position is basically a pointer to a pointer, is going to hold the address of this particular node, which is basically called root. Okay, so this position will be used to pass the information where the node will be inserted. That's where the position picture will come in, will play the role. Okay, great. So since the if part executed, the else part will not work in this context. So let's come to the creation of the node now. So this is the first time we are creating a node. So this node is getting created. So with the help of malloc, we created a node inside the heap. The address has been held by the pointer that exists inside the stack. Now we already have the data property with us, so we can pass the data value because the node has got the data. So that's what we are passing, and this is what been referred as the void pointer. So we are passing the data given by the user, and that's what we are storing it. Here we have already taken the input from the user, we have assigned the value right over here that got stored inside this parameter. So that's what we are passing it right over here. Since it's the very first node, so the left child and the right child will have null by itself, and that's what we have done it. Now this newly created node is inside the heap memory. I have to pass it to my tree, and for that reason we are using this pointer to the pointer. So the new node address is now getting stored inside the address that is called tree followed by root. So remember, the tree has the root, the tree has the root. There where that what was been pointed by position. So when you are assigning the address of the new node, that is been referred to this particular property. Hence the root is now holding the address of the newly created node. And since this is the very first node, so we increase the size of the node by 1, because we remember you have a property by the name called size, and that what got incremented. So at the end of this particular line, we have got just one node, and that is the root node being created. We are following the same track. Once again we are taking a new data once again in the form of 20, and we are giving a call this time again to the same function. But what we are doing this time is that we are going to assign the data as a left. So the new data that we are going to assign, the 20, will be assigned to the left of the root node, and that's the reason why previously we gave a call to null, but this time we will not give a call to null. Rather we are invoking a new function called binary tree underscore root. The binary tree underscore root function means where exactly the new node will be inserted, or you can think in this way that who is going to be the parent of the newly created node. So that's what we are going to do. So this is again a function, that function been called over here. If you see, this is a macro. So this particular function is going to return me the root. The root means over here who is going to be the parent. So what it is going to return me? It is going to return me this particular 10, so that I can assign 20 as a left child of 10. That's what it is going to return. So root over here means who is the immediate parent of the newly created node. That's what it is going to return. So this is a macro function call, and hence at the end we will get the address of the node that is 10. So this node address that is 10, this node address will be come right over here. So when we are giving a call to this particular function, the inner function will be executed first, and we got the address, and that what we are passing right over here as the second parameter. So again it will come inside this particular function, and this time it has got an address, and again we are going to check whether it contain address or not. Yes, it contain. So instead of executing the if condition, we will come to the else part, and it will check whether there is any node present or not. No, there is no such node present. So it is equal to null. So when it is equal to null, what will it do is that this node, which is holding the address of the first node, that is the root called 10, so I will be assigning, so I'm referring to this node left part. That's what I'm passing it to the position. So if you remember, it has got a parameter called star left, so left will be passed right over here. So we are passing, the position is now referring. So position property, always remember, which is a pointer to a pointer, will tell the tree exactly where to insert the new node. That is what the role of position is. Got it? So now we are creating a new node, and we are passing it the new node value to the newly created node inside the heap memory. We are making it blank both left and right, and the new node will now be assigned to the star position, which is basically referring to the left of the root that is called 10. So exactly this is what getting framed, and this being your second node. That's the reason the size is getting incremented, and that's how the left child of the root gets created. So let's come back and go for the right insertion. A very similar thing we are doing. Once again we are taking the input from the user, and this time we are giving a call to a new function called binary tree underscore insert underscore right, and again this function has been defined inside this file, but the function prototype has been mentioned right over here. So this was the left, and this is the right call that we are passing, which is almost the same but with a slight difference. What is the difference? This time we are going to incline it on the right side of my root node, but again this is the first node of the root, so the root node is no longer null. It will come over here, and it is a null value. So the address of the node, that means the root node, which we have already found over here. See, from here we got the root node. So this root node will give me, that means it is talking about the node of value of 10, that what it has returned. So that what we have got over here, so that has a property called write, because if you get back over here we have a property called write. So there where the position is now targeting, and now we are creating a new node, and that new node will be inclined to the position property, which is basically a pointer to a pointer. So as usually, we have created again a new node, and we have assigned the new node address. We have gone for the null for both left and right, and we are assigning that data to the position, and we have incremented the size with the value called 3 this time. So if you look at the diagram, exactly this is what's going to happen. Got it? So that's how one single tree got created. Now we are assigning one more time over here, and this time we are going for left of left. Got it? So we are passing again we are giving a call to the see over here, this call is very interesting. I've said left of left because if you look at the diagram, first you have to reach left, first you have to reach the root, from there you have to reach the left, and thereafter you have assigned the value 40. So I need to get the address of my left pointer of the root. So for that reason, first we are getting the address of the root. Once we got the address of the root, from there we got the address of the left. So this is how the call will be taking place. We got the address of the root initially, that is the 10. From the 10 we got the address of the left, which is 20, and there where we are going to insert now. And that's what is happening right over here. So when we come to this particular function, once again, so here we have gone for the macro, so it will return me the address of the node that is called 20, and that what we are passing it right over here. We are passing it into this particular function binary tree. So here we got the address of the node that is 20. Within that we are going to assign the new data. So this node is already having a value, so it comes over here, it creates a new node inside the heap memory, and we have assigned that new data that's called 40 right over here, and we have got left child, right child both null, and the position is targeting the exact location, and that is called 20. So there where we are going to assign it, and eventually we will get a formation of tree just like this. And that's being the fourth node which we have added, and the size property got incremented. So finally, when we'll come back to the code, we will see the total number of nodes that gets created is 4, and finally we'll also give a call to the destroy. So destroy will be responsible for clearing all the node that we have created. Again, if you go to the header file, you will find over here that we have a function prototype in the form of destroy, where we are passing the initial parameter in the form of tree. And that's what we are sending right over here, and we have to remove one by one the recursive call we are going to give in order to remove the left child separately and the right child separately, and finally we'll remove the tree itself. So already this video is pretty long. In my next video I will be talking about how the destroy function is going to work. Okay, so let me execute this particular program before we end up. So I give a call to this, and my program executes successfully. Now let me run the code just to see the total number of nodes that got created is exact. The tree size is 4, because you saw over here we have assigned 4 different values. For that reason the tree got created successfully, and it has calculated the size that is called 4. So size got calculated right from here. So here we are defining a macro, and that will give me the property size, which is a property inside this particular data type. So if you come over here, we have a property called size, and which was calculating when we did the +1 each time. So each time the function was called, we were adding this plus. So that's how we got the property, and finally the property got printed right over here, and that's the reason why we got the value 4. So I believe from this particular video presentation you have understood how exactly we can create a binary tree, and we can do the initial traversal to find out the insertion of each node within the left or the right child of a binary tree. At the same time, we also calculate the size of the binary tree itself. In my next video we will definitely discuss about how the destroy is working, so that once the program is done, how we are removing the initial tree that exists inside the memory. That would be the content of my next video. Until then, have a nice time. Bye bye.